I am Agung.
And this is Arman Ashabi.
We are master student of renewable energy in University of Malaya. We are going to present about the impact of smart grids on car company. There are four contents that we are going to talk. Firstly, introduction, business models and smart grids, design and P2G technology, and barriers and enablers. Within a smart grid where electricity is consumed and stored intelligently, battery storage is an attractive solution to bridge intermittency and provide flexibility. With the increasing electrification of the motorized transportation, powerful batteries of electric vehicles bring the opportunity to serve a short-term storage. In this context, the vehicle-to-grid V2G technology can be key enabler to an intelligent integration of EVs into the grid. V2G technology allows EVs to be fully integrated into the electricity grid and could have improved grid capability to handle renewable power.
Okay, so before going to the rest of this presentation, we should know about smart grids and the concept of smart grids and the area of workings. But now we want to talk a little about the difference between traditional grids and smart grids. As you can see here, traditional grids emit 25% of global greenhouse gases. So it's very high for the grids, and the reason is in the picture. But first we should talk about the traditional grids and smart grids that divided in two parts in the table at the left side. In each of them we can see characteristics of them. For example, for the traditional one, mechanization, one-way communication, centralized power generation, and the rest. And for the smart grid, digitization, two-way real-time communication, and the rest. On the right side of this slide, you can find the picture that shows the difference between smart and traditional grids. For example, in the production part, in traditional one, we just have some sources such as fossil fuels, but now via smart grids we can have new sources, new renewable sources such as biomass, hydro, solar, and others. Another example is in distribution part. As you can see in the picture, in distribution part we just have top to bottom distribution. It means we have one supplier and all of the other parts are demand side, and the supplier produce electricity and send it through grids to consumers. But in the smart grids, each of consumers can produce their electricity through new sources of energies, as I mentioned, renewable energies or biomass or other sources, and also they can send their extra production to the grids and they receive the benefits of this extra electricity. The advantage of a smart grid is communication between demand and supply sides. It means the supplier can see the amount of electricity needs in demand side and then can control the production to prevent losses of too much production. Our focus in this presentation is on the benefits of smart grids for electric vehicles and also how electric cars can support the lines through smart grids. We don't want to go deep into the concept because of limited time, so just needs to explain why the smart grid is a key to EV charging. EV is new in countries such as Malaysia, but consider some developed countries that using EVs are getting more popular there. By using EVs, the grid will face with several new consumers. But the problem is how the supplier can find out the maximum amount of usage to prevent collapse. One way is to increase the production that has several disadvantages, such as more emission, more cables, and more money. But now, with the ability of smart grids, we can use the battery storage of cars as a big reservoir of electricity to support the lines in peak hours and also prevent from collapse. Now, by understanding the concept of smart grids and the area of smart grids, we should know a little about business model and the relation of smart grids with business models. A business model is a company's plan for making a profit. Through business models, companies and markets could be compared and analyzed to determine effective ways of doing business. So, we know about the relation of smart grids and electric vehicle energy storage. And now, in our case study, Nissan, we will talk about how energy storage system of electric cars can support the grids and also have benefits for the company.
Well, according to Aziz et al. 2018, the basic concept of V2G is revealed in figure. EVs are connected to the bidirectional chargers to facilitate both charging and discharging. The EV owners have a contract with a certain aggregator which is responsible for controlling the behavior of EVs charging and discharging for ancillary service. In addition, aggregator also has a communication with the TSO as well as the electricity market to bid and participate in the available ancillary service programs. Once the aggregator won the bid, it will communicate with EVs and chargers to absorb or discharge the electricity from and to the grid respectively. 14 stated that there are two important applications of the V2G operation. Firstly, since renewable power generations such as wind power and solar power are intermittent in nature, the use of standby generators to back up the intermittent power outage is expensive, inefficient, and sluggish. Although the battery energy storage system can perform the desired efficient and fast backup, it is too expensive and bulky. The V2G operation can fully utilize the EV batteries to back up the intermittent power outage. Secondly, due to exceed demand and increasing cost, the V2G operation can utilize the EV batteries to absorb or buy electrical energy from the grid during the off-peak period, but generate or sell electrical energy to the grid during peak period. In 2015, at the 21st United Nations Conference on Climate Change in Paris, Nissan has announced the development of an innovative vehicle-to-grid system which will allow drivers to operate as individual energy hubs, with the ability to store, use or return electricity to the grid. It starts with one of the Nissan vehicles that designed specially for two-way grid connection. Leaf owners could connect to charge at low demand, cheap tariff periods, with an option to then use the electricity stored in the vehicle's battery at home when costs are higher, or even feed back to the grid to generate additional household income. And in 2018, EDF Energy and Nissan signed an agreement in the UK to work together to develop joint offerings in the areas of electric mobility, smart charging, use of batteries in second life, energy storage and renewable energy sources as well. Nissan V2G cooperation expanding. Nissan and EDF have signed agreement to collaboratively develop and launch a smart electric vehicle charging package for businesses including vehicle-to-grid capacity. The agreement, which applies to the two firms' operation in the UK, France, Belgium, and Italy, will see Nissan sell V2G compatible EVs to businesses, while EDF Group will provide the supporting chargers and services. The idea is to reduce the total cost of EV ownership for businesses by allowing them to charge their EV fleet when electricity prices and grid demand are low, and to discharge electricity back to the grid in exchange for payment when demand and prices rise. Vehicle-to-grid technology will put energy management back in the hands of the people by turning their Nissan electric vehicles into mobile energy hubs. Using the innovative vehicle-to-grid technology developed in partnership with Enel, drivers can store electricity in their vehicle's battery and return it back to the grid when needed. Imagine the home of the future. In the daytime, you can use renewable energy to power your home or office and charge your electric vehicle. When solar power cannot be produced and energy is in high demand, your Nissan electric vehicle can give power back to the grid. In return, you will qualify for subsidies from your provider as a reward for helping support infrastructure during peak times. During off-peak times at night, lower-cost energy can be drawn from the grid to recharge your car whilst little energy is needed in your home. With vehicle-to-grid technology comes cleaner power, lower energy cost, greater stability.
Such as all other new technologies, vehicle-to-grid concept has some barriers. For instance, there is no currently available operating EVs aggregator, especially for the large scale. Or the ancillary service market using EVs has not been established well yet. And also the trust in technology and motivation to participate by the early adopters are still low. In addition, further developments in technologies and supporting infrastructure, including charger and battery, are urgently required. But one of the important barriers is policy of governments. For using this new technology, governments should release new agreements and regulations to support it. Because electric companies will start to deliver new value when the government gives support to electric vehicle market through new policies. The policies, incentives, and tax system require significant improvement.
Future flexibility in V2G technology. Firstly, V2G is still an emerging area in the smart, flexible energy space, but the technology is rapidly gaining traction among businesses and policymakers. A 2018 study analyzed the potential value of utilizing EVs instead of new capital outlays for grid-scale stationary storage. Furthermore, V2G chargers can therefore help businesses generate revenues from vehicles that have previously only been a cost on their balance sheet, saving hundreds of pounds a year. You can imagine it. In addition, the UK government has announced it will invest €20 million to support V2G projects, while V2G offerings are now being offered by companies such as OVO Energy.
Now we know about the total concept of smart grids, advantages, and new technologies released via it, such as vehicle-to-grid system, and also how companies are working in this area, such as Nissan and EDF. Also, we know several companies are working through EV and smart grids, for instance Tesla, Volvo, and Toyota. It is the future of our lifestyle, and if we want to have a sustainable world, We should follow these kinds of technologies to have a better, cleaner, and smarter future.